All right, so last we ended on this note where we were saying, what happens if we forget to test this particular line of code? And we want to take a look at what actually happens. So in a command line environment, let's say we run some test cases and we see that in fact, we see hello test once, but not any other time. And we never see anything with regards to root. And it's interesting that when we type root, that is the time when we got hello test. Interesting. So we ran all of these tests after each other. We got hello test when we typed root. If we go back to this, why would that be? Does anyone know C++ well enough to be able to figure that out? Yeah, that's unfortunate. It doesn't actually walk it through with the next slide, but yeah, so kind of like how in Java we have the dot equals for comparing strings. Basically, this equals equals in this case isn't actually going to compare what you think it compares. You actually need to compare to a reference or a pointer rather than directly to an existing string. So if you try to do that, then there is actually no way to authenticate root in this application, which is unfortunate. So even though it looks like it might be syntactically correct, and you read this and you think, oh, that's just comparing the string to its value, that is not actually what's happening here. We'll get a couple more examples of this as well, but so you can use verification condition-based techniques to create some counter examples. So something like, if we can show the program is not correct and the input is a particular value, then you can use that, and you can use that to create some interesting test cases. One other thing you can do is you can find certain unreachable parts of the code by just putting an assertion in a particular part of the code. So we look at this if statement and find that, all right, maybe the issue is we think that we run these test cases and we can't actually get to the code inside of root. So now we're gonna make that assertion that says, this fails when we reach it. So to show that this is unreachable, just run your entire test suite over this, and this assertion should fail if it's reachable.
I just print out curse words so I know.
That works, but that's something that you really don't want to leave commented when you deploy this or your manager takes a look at it. This looks much more professional.
Have you ever seen that like 60% of C source code out there has just like shitloads of swears in it?
Yeah.
You know, I want
Too
to,
bad that they're too bad that that's kind of fun.
you know, I want to get to the point where I have the gusto to say, this causes a memory leak, screw you.
So yeah, we can see that with just an assertion, a test that automatically fails, that can show that at least in none of the test cases that we have written, have we been able to make it to that part of the code. One thing to note as well, just a few thoughts on specifications. Got to have a Dilbert in there because the more you study computer science, the more you look back at old Dilbert. And Dilbert was not funny remotely as a child, but the more you study computer science, you look back and think, wow, this comic was just so real. It's not even just funny, it's satirical. So writing specs is hard, we know this. But specifications can fail to be able to specify exactly the level of performance that you need for particular aspects. So for instance, one of the issues that you might run into, and I'm going to go down to now this Does this code compute the sum of 1 to n? If so, what is the associated complexity?
Geometric. 1, 3. Okay.
So 2 questions. Does this compute the sum? And what is its complexity?
Yeah, it's a geometric sum theory where you go from 1 to this, and so you just match 2 pairs of each. Multiply, and then you divide it by 2 to get it, so you don't have to add 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc.
I can go through the intuition to show why this kind of expression would work. The issue is, it's not the right expression. Does anyone see the mistake in the expression?
N minus.
That should be a plus, not a minus. So even though this is another reason that we go through and do peer reviews. Not peer reviews, but we want to make sure that code reviews can catch these kinds of things, but it's difficult if there are small issues in the code. Because I'm pretty sure that all of you would have just allowed that code review, that pull request to actually go through.
Well, yeah, then when it breaks, we'll figure out it's broken. We'll fix it.
Right, so if we have continuous integration and someone wrote a test for this, then you would find it. But maybe the coder just said, "Oh, I know what I'm doing. I'm just gonna push this through. I don't need to write a test for it. It's simple enough, right? There's no way this can possibly be wrong." This is why we write tests for everything.
Off by 1 error, so no jokes.
What's the complexity?
It is quite interesting. Have code that got pushed and then you go to run it. It's like, they not even try to run the program.
But this is constant complexity, right? It doesn't require, as n changes, the time that it takes a computer to run this code does not change.
Okay, that, you're asking time complexity.
Yes. So here's another example. Aside from the obvious syntax mistake.
The compiler will catch that for you.
Yes.
Thankfully.
So again, I ask you the same 2 questions. Does this compute the sum and what's the complexity?
In the geometric sequence, do we want to include the final n? No, it should do that.
Yeah.
We're not getting total. Or not getting end with the.
Yeah, so we're updating total, but returning
n.
Yep, that's the issue.
Um,
So again, something that's very easy to miss in a code review, this is why we write the tests. Because even if you spend 30 seconds to a minute staring at this, what looks like a very simple function, the issue is there. It's worth writing a test because I've made this mistake before, and then you run it and you catch it. I'm pretty sure just about everybody has made a very similar mistake to this throughout the course of your history. So even something this simple deserves 1 or more tests written for it to verify that even in the simplest cases, this code is correct. So that's why I wanted to do this, and I skipped around a little bit to be able to get to that, because now when I go back and say, we can talk about an example summation. Here's the plus, not the minus. So I'm gonna skip past that really quickly before people saw it and then can apply it to the other example. But example of summation, we can implement this in different ways. You have to know that there is a trick to calculating this sum before you can know to implement it in the faster efficiency way. But that's what specifications and tasks can help you with. If it's not embedded in the specification that this needs to be implemented in constant time, then either of these are going to be correct implementations. Either of the code versions that we just went through are going to be correct implementations. But obviously one is better than the other. So another reason that we write specifications, and when we go to the task, it's important that that information is embedded in the task. Because the person who wrote this task may not be the person who goes and implements that task. The person who writes the task says, all right, we just need to sum from 1 to n, simple enough. I'm just gonna leave that as the task. Someone else goes, grabs it and says, oh, it's just a simple loop. All right, I can write that. And now there is a mismatch between the client's expectation of performance and how your code is going to be able to handle that. And again, there's nothing wrong with the code itself. All the tests will pass unless you have some test that's associated with the system clock. And maybe you try to write a test for the sum from, I don't know, 1 to 500 million. And you expect that that is going to take under a millisecond. You could do that, but it seems like you would be making a lot of those tests for every small piece of your code when you could have something that's more efficient than something else. So efficiency is always worth considering. You can add some contextual properties. So you will apply them at particular places in the code. You can do something like assert that something is not true. Or so an assertion that should never fail. Here's an example of in the middle of a binary search. By the time that we calculate the midpoint, we should say, well, the midpoint should be within the bounds of the array. So rather than getting an array index out of bounds exception in Java, or even worse in C or C++, if you did something that gave you just a segmentation fault. Because we see how useful the error messages are for segmentation faults. For those of you who've taken C or C++ based classes, you don't get a nice exceptions call stack that tells you the line number, what happened, you just see segmentation fault. You can add these assertions in the middle of your code that will, it should always be true. It's not something that should ever be apparent that this test even ran, because they should always be true. That way, if you do get a segmentation fault, you will see that it's actually the assertion that failed, or we never got to the assertion. That can be useful to help you understand that at this particular point in time in this program, the midpoint is a valid value. So I think that's basically everything I wanted to go over. Questions about anything about formal verification? I really wish we had a programming languages course here so that we could actually talk more about things like calculating weakest preconditions. Because there are some examples that I'd like to go through that I just don't think that we have time for, and it's not quite as relevant to the concept of software engineering, but it would be useful for the concept of formal verification. I don't know. We're basically out of time in the quarter though. Questions or concerns? All right, I will note as an announcement, the study guide has been posted. So we said there's going to be a quiz on Monday. If people have had a chance to look through that, then I can field some questions about that study guide, if that would be useful, since we're not going to have a review period or really time ahead of class for that. So do note that I will be in my office that hour before the quiz, but that's not a ton of time to take feedback from a question and go iterate on it and study it or get to know it better, get some practice with it. So if there's anything conceptual that I could answer at this point, I'd be happy to do that. Otherwise, I will be in my office for at least the hour ahead of the quiz if you come up with questions over break. Anything else people want me to cover?